Hello and welcome to lesson number 4 in Unit 2A, Quadratic Functions, Forms and Transformations in our grade 11 University College math class. This is analyzing the roles of a, h, and k in y equals a bracket x minus h all squared plus k. Whew, that's a long title. Okay, think of this more as like a review lesson basically. We've gone over 2 days of transformations in vertex form and what they mean, what the variables mean, and what they how we represent transformations using those variables. It's just a review. We're going to fill this out. I've already got most of it filled in just to save myself some writing, but I'll talk you through each section, starting with the role of a. Now, a is the variable that sits at the front. As you can see sort of in the bottom right-hand corner, there we have our vertex form. So what does a do? A dictates two things, and they're separate. The first one is direction of opening. If your a value is positive, your parabola opens up. If your a value is negative, your parabola opens down. And again, that doesn't have anything to do with the size of the a value. It just has everything to do with just the signage, just whether or not it's a positive or negative number. That dictates the direction of opening. The second thing that a dictates is the shape, whether or not your parabola is compressed or expanded. So the way that it works is that if a is greater than 1 or smaller than -1, so that's sort of a longer way of basically saying a is a number larger than 1, either positive or negative, then we would say that that is a vertical expansion by a factor of a, and it is a narrower graph in appearance. If a is between -1 and 1, which is sort of a proper way, or another way of saying if the a value is a proper fraction, so a smaller numerator than denominator, either positive or negative, then this is called a vertical compression by a factor of a, and that results in a wider parabola. So that's a. It tells you two things: direction of opening, and as well how narrow or wide your parabola is going to be compared to the parent function. Let's jump over here to the role of h. H is our horizontal translations. So if our h value is larger than 0, our graph is going to be horizontally translated to the right. And I do want to make sure that we point out here as we're going, this one actually appears negative. And the reason it appears negative is because inside that bracket, we've already got a negative. So for us, it's like having a negative and a positive banging up together. It's going to appear negative, but it's actually a positive value, and it is a vertical or a horizontal translation, h units to the right. Similarly, if your value for h is less than 0, i.e. a negative number, it will actually appear positive. Because again, a negative banging up against another negative value, if we are going to simplify that to a single sign, it will be positive, even though it's a negative number. And those would be horizontal translations, h units to the left. The value of h is the x-coordinate of the vertex. It is also, value of h, it's also the axis of symmetry. Axis of symmetry, which as you can imagine, will run right through your vertex vertically. Axis of symmetry too. Okay, so there's your h value. Let's jump over here and look at k. So k is the constant that shows up at the end. This represents vertical translations. And what's nice about k is we take it at face value. If the k value is larger than 0, so any positive number, it's going to be a vertical translation k units up, and any k value that's negative will be a vertical translation k units down. The value of k is the y-coordinate of the vertex, so you can see how h and k correspond respectively to the x and y components of the vertex. Here's a couple of things, and this is going to show up a little bit later in our lesson that I want to make sure that we note here. If k is equal to 0, then the graph has one and only one x-intercept. And why is that? Because it would be sitting right on the x-axis. So only one time does it touch or intercept the x-axis. If our k value is going to be bigger than 0, so we've moved our graph upwards, there are two possibilities. It can either look like this, where it's above the x-axis and it opens up, which has no intercepts, or if it opens in the other direction, it will have two intercepts. It really just depends on the value of your a. But the value of k doesn't immediately tell you how many intercepts there's going to be. And similarly, if you have a k value less than 0, so i.e. a negative number, it doesn't necessarily tell you how many intercepts there's going to be. I'll just erase this one over here. If you have a vertex that is below the x-axis and it opens down, it will have no x-intercepts. If it opens up, however, it will have two x-intercepts. So that explains the bottom ones right there. It's a function both of direction of opening and the y component of your vertex. So that's your review of the transformations that we make to y equals x squared in vertex form. Now we're going to do an example. So here we have y equals -2 x minus 3 all squared plus 5. So let's dissect the transformations as they've been provided to us. So first off, what is our direction of opening? The direction of opening, we get that from our a value. We see that it's negative, which means that our parabola will be opening down. Whether or not we have an expansion or compression, we now look at the numerical part of the a value, and it's a 2. So 2 is larger than 1, so we're going to call this expansion by a factor of 2. Oops, expansion, vertical expansion specifically, by a factor of 2. And now the transformations in order. So we're going to list these things out. Well, we've already got 2 of them, right? We've already talked about how this is a reflection across the x-axis. That's the negative sign there, x-axis. We also have vertical expansion by a factor of 2. And now we're going to look at the other 2 components so we can get our list going on. So the next one down the line is going to be this value right here. It's a horizontal translation. So a horizontal translation, and that is 3 units. Now that looks like a negative value, is actually a positive value, so that will take us 3 units to the right. Last but not least, the vertical translation right here at the end, which we take at face value, so that is a vertical translation, 5 units, and that is a positive value, so that will be going up. So those are our transformations listed in order. The coordinates of the vertex, again, we take that right from the h and k value. So in this, we have h and we have k. Now remember that that -3 is actually a positive 3. It just appears like a -3. So that would be 3, 5 would be our vertex. Now the number of x-intercepts, this is one of the new-ish things that we're going to be tackling today. So what I'd like to do is illustrate this using a little bit of a sketch over here. So here is a coordinate plane, and my vertex is over here at 3 and 5. So say it's up here somewhere. Now what is the direction of opening of my parabola? We've already determined that it's down, so we know that there will be 2 x-intercepts. So that's what I'd like us to write down here. There'll be 2 x-intercepts, and now the domain and the range to finish it up. Domain, nice as always, with a theoretical parabola, it's wide open. So the set of all x such that x is an element of real numbers, no limits. Now the domain, or the range rather, is limited by our vertex. So let's start it off, the set of all y such that y is an element of real numbers where, so we're dealing with y, and we're looking at the y component of our vertex. The y component of our vertex is 5. So that's the important number we put there. And our direction of opening is going to be down. So that will be less than or equal to positive 5. And so there is our domain and range, a fully worked example. Now I want you to sort of make a note of this, make sure you've got this copied down, because as we head to the next page in this lesson, which actually also corresponds to the homework you'll be completing tonight, we're going to work through a whole bunch of these, including all the stuff we just did, a value, h value, k value, vertex, number of x-intercepts, listing of transformations, and then the domain and range. So we got a boatload of these to get through. We might as well just stop here, and we'll pick up a couple of these examples in part 2 of this lesson. So we'll see you in part 2.